So in this video we're going to handle compass mathematics, and to be specific, I'll be handling calculus. So this is an introductory topic that most of the courses will have to handle. In engineering they call it engineering mathematics, in economics they call it calculus 1, 2, you can even have 3. So I'll give a brief overview. So calculus is split into 3 areas. So the first area is normally differentiation. Differentiation is what you actually introduced into, that's calculus 1. And then the second calculus is integration, and then the third calculus is vector analysis. So from vector analysis, now further, if you go further, that's normally in engineering, so I won't cover that here. So I'll cover the first 2 areas actually, differentiation and integration. So today we start off with the differentiation. So in differentiation there are rules, and so we have rules, and I'll give a general principle of how to differentiate. So a general principle is that when given a function f of x, that is a x power n, then the general function states that you're supposed to take a times n. Okay, sorry, so let me just correct that. So just to clarify something, so if you to integrate this, I mean to differentiate it, so d of dx, which is the same as f of a of x, should be given by a multiplied by n, then x multiplied by n minus 1. So this is a general principle. So if you're given a function, for example, so e.g., so f of x is given by 4x power 5. So in this case, this is our n, this is our a. So for f prime, so f prime of the first derivative, so this will be given by 4 times 5, then x power 5 minus 1. It's a simple principle, and this goes without saying that this becomes 20 x power 4. That is the principle. So anytime you're given this, anytime you're given a differentiated equation, you should know that this is the way to do it. But now the principle, this is just a general principle. So this is the first derivative. So let me explain further that in differentiation we have first, second, third, and if possible fourth derivative, depending on the power, which polynomial you're differentiating. So if n equals to 4, you can go up to 4 derivatives. Yeah. So for instance, let's give an example. So if this is 3x power 4, so the first derivative, which is f prime of x, will be given by 3 times 4 x power 4 minus 1, which is equals to what? 12 x power 3. That's the first derivative. The second derivative will be given by so the second derivative, which is f double prime of x, will be given by this, which is 12 times 3. So simply the second derivative is a derivative of the first derivative. So this is 12 times 3, x power 3 minus 1, which should give you 36x power 2. Then let's proceed. So that is the second derivative. The third derivative should be let me change my pen. So the third derivative should be f double prime, triple prime of x should be given by 36 times 2, then x minus 3, 2 minus 1. Sorry, let's clear this. So x 2 minus 1. So this should be what? This should be 72 x power 1. So basically it's x. So that's the third derivative. The final derivative should be given by the derivative of 72x. So now instead of fourth derivative writing it, we should write f power 4. f4, which is the fourth derivative, is given by 72 derivated, that is times 1, then x1 minus 1. So this should give you 72 x power 0. But what is x power 0? 72 just times 1, which should give you 72. So that's how you you differentiate functions as you drop down to the nth derivative. So this is just a general principle on how to differentiate, but now there are rules. So the rules behind that, the first rule, so let's go to rules. So let me just highlight this and say, so we have rules of differentiation. Rules of differentiation. So the first rule states that so d of dx, so this is the addition rule, f of x plus g of x should give you so the answer is f prime of x plus g prime of x. So for instance, we give an example. So assuming you're given d of dx of 4x squared plus 3x, this should be equal to 4x squared prime, then plus 3x prime. That is the first derivative. So how do you proceed with that? So the next thing is so how do you solve that? So this becomes, so I remember the rules of differentiation is 4 times 2, so that's 8, then x power 2 minus 1, which is 1, so you don't need to include anything, plus this is when x is alone is power 1, so 1 times 3, that is 3, then x 1 minus 1 is 0, so that is 1, so you don't need to include it. So that's the answer. So this is the first so this is the first so this is the first rule. So you proceed to the second rule. The second rule is the rule of subtraction. So d of dx of f of x minus g of x will be given by f prime of x minus g prime of x. So an example in a question is that you differentiate what is the derivative of 2x cubed minus 4x 4x, I think 4x, yeah, let's just do 4x. This should be, so as I said, so this should be 3 times 2, that is 6, x power 3 minus 1, that is 2, then minus 4 times x is power 1, so 4 times 1, that is 4, then x power 1 minus 1 is 0, you don't need to include it, so power 0, this basically means 6x squared minus 4, and this is the answer. It's simple as that. So we proceed with the third rule. The third rule states that the third rule is the law of it's a power rule. So well, let's proceed. Let's go to, so the third rule is the division, not the division really. So the third rule is the product rule. So d of dx into f of x multiplied by g of x. This should be f multiplied by g of x, then plus g prime of x multiplied by f of x. So notice this, that in the first function multiplied by the original second function, then plus derivative of the second function multiplied by the original first function. That is simple. So I'll give an example. So we say this. Let's give an example. So let's give an example. So e.g., you're given d of dx of 3x squared into, like, multiplied by 2x. So what is the answer to this? So it is simple. You take the derivative of the first function, that is 3x squared, then this, take the derivative multiplied by the second function, that is original, then added to 2x derivative, then multiplied by the original function, first function, 3x squared. So let's do that and see. So let's proceed and see. So what will be the answer? So this gives us what? So 3x